Okay, good morning, everyone, and thank you for attending this seminar today. And also thank you very much for giving me the opportunity to introduce our smart manufacturing. I am Naomi Momoki, and I'm responsible of promotion of Fujitsu Monozukuri Solutions. Monozukuri means manufacturing in Japanese. And also, I am very happy today to have the first joint seminar between DreamEdge and Fujitsu. And the collaboration between DreamEdge and Fujitsu have started a Fujitsu CAD system. And we have started the sales of Fujitsu iCAD SX, which is a Fujitsu CAD system in Malaysia. And now we combined DreamEdge very high-level engineering service and Fujitsu Japanese quality to have to provide more highly value-added service to our customers. And with this seminar today, we hope that we're going to strengthen our further collaboration for our customers. So I would like to start the introduction of our manufacturing. So first, I would like to briefly introduce what Fujitsu is. And Fujitsu is a Japan-based global ICT company and seeking affluent society with customers by utilizing ICT technology and our experience. And this is a Japan market share by industries, and we have the top share in most industries. And now we are working with worldwide, world-class customers, and these are the customers which have been approved for usage in this presentation. So let me move on to the manufacturing activities. In Germany and United States and Japan and other countries, we started the effort to rehabilitate the manufacturing industry. And these activities utilize the IoT and utilize information from the design and manufacturing and also supply chain in the manufacturing. And also, we have started the approach that, and we have our characteristic activities in each country. And we, Japan, have started with a flexible connection factory. And all of us try to the best case of the manufacturing in each country. And Fujitsu is actively working with the Industry 4.0 and US IIC, and we also participate in organization representing Industry 4.0 in Japan. The top two, RRI and IBI, are representing the organization in Japan. And the difference is RRI have more relation with Japan Ministry of Economy, and IBI have more relations with company side. And I'm also a member of RRI, and many Fujitsu people participate in this organization and trying to the best case for standardization to connect with other companies. And these are the activities of Fujitsu business, and 40% are business from products. So we are not only ICT vendor, but also the manufacturing company as well. And these are the manufacturing sites all over the world. And our manufacturing site mostly exists in Japan. And we feedback experience and technologies of each site, and we offer those know-how and experience as Monozukuri, the manufacturing solution, to our customers. And we have used our own ICT for manufacturing since the dawn of ICT. And we introduced the Toyota production system to promote, innovate our manufacturing and expand it into the development division. Finally, we evolved as FJPS. FJPS is a Fujitsu production system. And our own ICT plays a very important role in FJPS. And we unified various tools and integrate as FTCP. FTCP is a flexible technical computing platform. And now almost 3,000 people are using this cloud service in Fujitsu people and using the remote control computing system. And we are trying to daily challenge to advance the development process. And based on these activities and the know-how and experience, we have been offering monozukuri solutions. So now I'm going to introduce you some of our solutions. And first, I would like to introduce smart collaborative engineering. Not only design, but also production and procurement and maintenance can review the design for the next models. And even if they are in a remote place, sometimes the design team is located in a headquarters and the manufacturing site is very far from the headquarters, but they want to review the same models as if they are in the same place. So with this solution, they can review the models as if they are in the same room with remote technology. And also that sometimes that it's difficult for procurement people and manufacturing people to image the product just with 3D data. But with this solution, you can review the models as if you have the real product in front of you using the stereoscopic view. And also you want to check some problems from each part, from the shape. If you want to see some problems with this shape, you can check from the photograph of this shape if there is some problems in the past from the database using AI technology. So now I would like to show you the image of this smart virtual OBR. Sound is not coming. Sorry, that sound is not coming, but now they are reviewing the new product. So you can see that they are wearing the glasses to see the stereoscopic view. And now that system is searching the troubles from the past information. And they are in a manufacturing team. They are very far from the headquarters, but they are reviewing the same models. And usually 3D CAD data is very heavy, so it's very hard for you to review the model in a remote space. But using this technology, you can see that models without any stress. And this is searching the similar 3D shapes with using AI if there are any problem in the past from the database. Okay, this was the smart collaborative engineering, which is one of our solutions. And just for the difference, Fujitsu and the Advanced Remanufacturing and Technology Center in Singapore announced a strategic partnership to accelerate the pace of digital transformation for factory for the future. And this is another solution called 3D Chojo. Chojo means superimposing and overlapping. And this is the 3D design manufacturing solution, which is used to check the manufacturing mistake by superimposing the 3D models and product photographs. You can check the product easily by preparing a 3D model and product photograph before you go to the assembly site. And this is also used by some Japanese customers, and I would like to show you the user case using the movies.
Tomoe Corporation was facing an issue. They were using human eyes to examine the manufacturing parts, which was leading to simple human errors, causing assembly mistakes and incomplete inspections. Tomoe Corporation had already developed their own system, but consulted Fujitsu for a system better suited to them. Fujitsu believed that they would be able to resolve this issue by integrating their knowledge.
まずはじめに友江様から技術相談を受けたときに真っ先に AR の技術が使えないかと思いました。
今までのマーカーをベースにした富士通の AR 製品ではどうしても解決できなかったので、マーカーを使わない AR 技術の開発に今回着手しました。スマートデバイスをかざしたときにぴったり重ね合わせて表示する、そういった技術になります。
いろいろ試行錯誤したんですけれども、マーカーを使わずに物体を認識してそこに 3D のモデルをそのまま重ねるということでお客様に提案してきました。
現場の人間が簡単に使えて、目視の場合よりも作業時間が10分の1ぐらいに短縮しました。今後は CAD/CAM を含めた生産に関連するシステム全般に広めていきたいと考えています。
Making the future by connecting knowledge. Fujitsu Knowledge Integration.
And the next solution is BPS and GP4. This is used by the customers in other countries than Japan. And BPS is for design process of manufacturing using 3D CAD data, inspecting design and inspecting productivity and front loading for production preparation. And GP4 can automatically simulate the movement of man and flow of the materials. And we are using these tools in our factories. So I would like to show you the image. And this is overlapping the result of the GP4 simulation and actual movement of the production site. Can you see the colored man? This one is from the simulation of GP4, and white one is the actual movement. They have the beacon sensor with them. And by comparing real and virtual in this way, you can find problems and work at flow line and the movement and factory layout. Then you can optimize them. So from now, I'm going to introduce you some AI cases. The one is, this is image recognition using AI in production. We offer image recognition algorithm that is generated automatically using machine learning technology. It is not deep learning, but genetic algorithm. So you need only few pictures to get algorithm. And this is very good for the production of new product when you don't have enough sample pictures. And compared to expert engineer, it costs 1/10 to generate complex algorithm in a Fujitsu factory. And in a certain case, the recognition rate has been improved from 50% to 90%. And this is another solution. This is a service of AI for Siemens wind turbine manufacturer. Ultrasonic quality inspection generates massive amount of blade scan data for quality control. And this scan data evaluation process is now completely automated. And it enables skilled operators to focus on more important part of the data. And inspection time for wind turbine blade is cut from 6 hours to just 1.5 hours using these solutions. And another case is, this is a case of electric power company's thermal power plant. They measured the temperature with optical fiber and analyzed the correlation of the temperature distribution. By catching the sign of anomaly that differs from the past normal temperature pattern, they succeeded early detection of lead heat. So now I'm going to introduce some solutions which is used in production. So this is mass customization of SMT line to improve productivity of small lot. And you can optimize setup work with accurate inventory information for each lead part. This is also used in our manufacturing site. And another solution is for picking operations. As of one of our efforts at our factory, here is an example of ICT utilization of picking. Then the workers are pushing a cart for picking, and they will be instructed for each work procedure, and they have put the band with equipment on their arms. And if the picking is not correct, the machine is trembled. Then production is Fujitsu factory is a mixed production and many kinds of product. And they product on the same line will be different. And accurate picking is very important. So we try to make efficiency of production with this solution.
こちらはストーピッキングのコーナー。ここではピッキングカートシステムを活用しています。
So this is movies in our factory site. Now they are picking the instruction. The cart has this tablet, and he is now picking, looking at this tablet. And another solution is price management. And in order to catch where the repair product is located, RFID is attached to each product, and repair items are moved from repair, but sometimes the location is not clear. They are looking for by themselves before, but now it can be tracked by RFID. And they are trying to improve work efficiency with this solution. So now let me introduce our new solution, Cormina. And before introducing Fujitsu Cormina solution, I would like to briefly explain the manufacturing situation in Japan. This chart shows our customers' request regarding AI and IoT for their manufacturing. And about half of them want to utilize IoT to improve factory operation, and 20% want to utilize AI for their manufacturing. I think that our customers' requests about IoT and AI are very high. And Fujitsu is the only vendor in Japan that can develop the applications for all areas. And we have been selling a range of manufacturing solutions for more than 30 years. And these are the name of the solutions which we provide for the manufacturing customers in Japan. And more than 10,000 companies are now using our applications for their manufacturing. So we announced Cormina on this May, and Cormina is the collective name of manufacturing solutions that covers all stages manufacturing. And Cormina enables collaboration not only with business system, but also the supply chain between companies. So Cormina provides standard interface for collaborating with other companies' solution and platform. And connecting various scenarios not only improved production efficiency, but also creates new business models and ecosystems for manufacturing industry. The Cormina provides three values: digital monozukuri and improve supply chain and creation new services. And Cormina has three layers. The first one is a Cormina service, which provide a lot of manufacturing applications, which I introduced just now. And Cormina Edge is collect the data from machine and equipment in a factory site. And Cormina platform connect Cormina service and Cormina Edge, and which has IoT technologies and AI technologies, and also standard adapter to connect other systems. And in the layer of Cormina platform, the data is stored standard adapter, and IoT platform, and big data platform, and accumulating data is analyzed in cooperation with Jindai, which is Fujitsu AI platform. By analyzing data, Cormina service provide various utilization, such as service of process visualization and fault prospection. And Cormina has support high quality manufacturing. And this is a list of service offered as a Cormina service. And this intelligent dashboard is the first service which is provided on Cormina. And red line is the service, the 5 service. We are going to start with the next version. And this is a summary of our customers' request on digital innovation. And the size of the square is proportional to the number of demands. And you can see the need of visualization, the center, the one, is the highest. So this is the reason we start to Cormina service with visualization service. And here is a screen of factory dashboard. In dashboard, it is possible to drill down the state of from factory as a whole to line and equipment. And it is possible to find anomalies in factories and visualize the operating status. And Cormina version dashboard provides a standard screen and setting screen beforehand so that you can change the display yourself at the time of increasing equipment and line recombination. And this solution is already used by some Japanese customers, and I would like to introduce some cases in the next presentation. And this is another visualization service, which we are going to start with next version. This is called Visualine, and Cormina can provide not only service of Fujitsu, but also solutions from other partner companies, which has a control manufacturer. Visualine is a joint achievement with Omron, and we plan to add such services in order. And we have the exhibit for these kind of solutions outside this room, so I'm very happy if you are interested in those of them. You can see the details later this presentation. And these are the services which is started with next version. Order delivery risk monitor and process visualization and facility operation monitor and production collaboration, which is used for supply chain. So based on this technology, we'd like to contribute our customers' business in manufacturing industry to be a good partner with customers. So this was all which I would like to introduce you today. Thank you very much. And please feel free if you have any questions. Thank you.
Thank you for introducing me. Selamat pagi. Oh, thank you. And thank you for coming today. My name is Kazuya Yamaura. I'm a PLM Solution Department Director, and I am a PIC of DreamEdge Fujitsu collaboration for the activities in Malaysia. Today, I'd like to talk about smart factory solutions to visualize manufacturing process using IoT. So here is the agenda of my presentation. I'd like to start with the industrial manufacturing trend in the world, and then I'd like to talk about customer case studies with practical sample movies. And then finally, I'd like to give you my proposal for the path to smart factory. The first topic is industrial manufacturing trend. Recently, a lot of countries have begun to see domestic process is more important rather than outsourcing the process to overseas. In fact, you can already see the activities in some countries, as Momoki-san mentioned in the first presentation. There are all movements which is actually happening to achieve smart factory and smart manufacturing. As one of the examples, let's see the current investment trend in Japanese manufacturing industry. This slide shows Japanese factory have experienced generation of process management and factory automation. And now they are facing on the new generation of IoT. In those past time, tons of data was just stored, but not utilized. However, as the generation goes on to IoT, the unutilized data started to be analyzed and used to satisfy the market requirements. As a result of these movements, now an investment target is changing from facility into IoT, like sensors, RFID, and cloud infrastructure, and so on. Let's see the recent trend from an aspect of numbers. Here is a survey from government white paper, Ministry of Economy, Trade and Industry. They conducted this survey 2 years ago. They categorized companies into 5 groups in activity level for IoT from many questions here. And in this case, Group E here, Group E has the most positive response for IoT. So we'd like to focus on Group E. Here is the survey results. The first question is, did you speed up your decision making than 5 years ago? And the second question is, did you shorten the lead time than 10 years ago? Actually, nearly 50% of respondents in Group E answered yes to these questions. Another survey result from a viewpoint of small company, less than 100 employees. The questions are, will you increase the capital investment in 3 years? And will you increase the salary next year? And interestingly enough, there was a positive correlation between these questions and the grouping. And a very strong correlation was observed, especially in a small company. Okay, here is another survey which was conducted by a public well-known magazine, Nikkei Monozukuri, in Japan. It was a very direct question. Does your company do something with IoT? So according to this chart, 53.7% of companies use IoT in some ways, or at least plan to introduce it. I think it's a very big number and a very big movement. Okay, here is another survey from government white paper, Ministry of Internal Affairs and Communications. They compared issues complicating IoT progress between 6 countries. 6 countries have common issues in the area of IoT infrastructure, here blue, and rules, standardizing rules, they are orange here. So on the other hand, Japanese enterprises in particular tended to view personnel training as an issue more than those in other countries. So therefore, they concluded that employee training and publicizing IoT usage scenarios would be needed to further IoT use. Okay, when it comes to introduction of IoT, it can be said that there are 2 major axes, domains and steps for smart factory. In general, domains of smart factories are various dependent on customers' demand. On the other hand, steps have been standardized gradually. For example, collecting, visualizing, insights, analytics, action, and so on. So this is because you need at least to collect data first in order to visualize something. For example, I will show you a case of Toyota Motor Corporation. According to this article by Nikkei Monozukuri, Toyota Motor Corporation puts forward these 4 steps. And these steps will help them not only to improve productivity and quality, but also to acquire an advantage in employee training and further customer satisfaction in the near future. Here is another reference from an article from Nikkei Technology Online. JTEC Corporation mainly manufactures and sells automotive components and machine tools and so on. They put forward these 4 steps and aim to adopt customer demands flexibly by putting standardized solutions and products together. Then, how exactly this smart manufacturing can be achieved, Fujitsu will provide not only hardware devices such as sensors, telecommunication equipment, RFID, but also software services such as application software on cloud infrastructure, which is called Columina, as Momoki-san mentioned in the first presentation. We think the important thing is to provide a place for connectivity. Okay, now let's move on to the second topic, customer case studies. When it comes to smart factory, we think that key point is to connect something. So the important question is, what can be connected? What do you want to connect? What kind of benefit does a connection bring to us? So we will answer these questions by sharing some customer case studies with short movies. Firstly, to connect equipment. Case number one is example of Omron Corporation. Omron is an electronics company in Kyoto, Japan. They produce various parts and equipment such as sensor, automotive control units, and medical product, and more. And Omron tried to visualize production line to improve productivity. To be concrete, they collect log data from 4 different machines in a factory. And they put them into the database and visualize a very simple line graph to improve the productivity. So please take a look at the 3-minute short movie.
製造ラインの改善は現場で常々行ってきました。しかし何年も続けていますと次第に行き詰まり感を感じるようになりました。
いろんなその機械のデータが集まってきますので、ただそのデータが集まってきてもですね、どのように活用したらいいのか、それが課題でした。
現場の実際の製造ラインから取れるデータっていうのを集めていただきました。データを活用するとどんなことが分かるのか、いくつかの仮説を立てると、機械から取れるデータの中に生産実績につながるようなデータを見つけることができました。
4工程で構成するプリント基板の実装ラインがあります。この各種機械からリアルタイムでログデータを集めるためにシスマックを活用しています。
富士通はシスマックが集めた各工程のログデータを紐付けるシステムを開発しました。さらにこれらの紐付けたログデータを加工して工程別の生産実績とボトルネックが一目で把握できるレポート、タイムラインデータビジュアライゼーションを提供しました。
視覚的にすぐに異常が発見できるところが良いと思いました。
このレポートは我々にとっては非常にたくさんの情報が提供されています。超一流の技術者にしか見極められなかった生産全体の無駄がレポートを見れば誰でも見つけられるようになりました。
膨大なデータを使うほど現場の人はデータを理解することに苦労します。このレポートは直感的に可視化することができます。さらにデータを追加し続けても全体を見渡せる点が評価されたのではないでしょうか。
ベテランでも6時間かかってやっと見つけられていた改善ポイントを誰でも1時間で見つけられるようになりました。その結果ですね、1時間あたりの生産性が数ヶ月後には 15% 向上しました。今では 30% も生産性が向上しています。いや、30はすごいです。
レポートを見て効果が目に見えることが皆さんのモチベーションにつながっているようで嬉しいですね。
解ができることっていうのが増えた結果、そのデータを収集して見える化すると、人間がですね別のところに注目し工夫ができるといったところが、現場のですねエンジニアたちが喜んでやってるのは、そういう面が充実してきたからじゃないかなというふうに思ってます。
日本はですね、やはり人と人のつながりでそのものづくりができるというふうに思っています。一番重要なのはやっぱり人だと思っています。
データ活用をさらに進めて生産現場のパフォーマンスを上げていきたいですね。富士通は人と機械が協調して働ける次世代ものづくりを ICT の力で実現しサポートしていきます。
Okay, Omron achieved to improve throughput dramatically just in 1 year since they introduced this system. And in the left picture, there are some blank space here. So it means there were idle time for some machines due to certain problems. On the other hand, in the right picture, the blank space radically decreased, which means machines work efficiently without wasting of time. This slide indicates that product manager is comparing the performance between the pilot factory in Japan and new factory in Shanghai, China. So this line graph enables anyone to recognize the factory's situation easily. Therefore, they can identify a bottleneck and find a clue to improve their factory's performance. Okay, the next case is to connect factories. Case number 2 is an example of one of the Japanese tier 1 automotive supplier. The key for their success was simplicity and speed in access to warning or alarm information in a factory. I will show you a demonstration. For your information, the whole real data was modified intentionally for a demonstration. In the left zone, you can see here operating rate of the whole factory. And in the bottom part, you can see 4 graphs here. Production efficiency and wasted amount and the number of workers and the CO2 emissions. Okay. So if there was something wrong with the production line, a red notification would pop up on the screen. So now let's click the red alarm. Here. In this case, line E has some problem. Okay, then you found out the notification came from, say, welding process here. Here. And then now click this welding machine information. And in this demonstration, notification says that front door is opening and the welding machine is freezing. So now, if necessary, you may send technical staff to the area and fix the problem, and or you may order the changing of old components and so on. So furthermore, you can check the performance of each production line, such as where is the cursor? Okay, here is the failure rate of each lines. productivity, and the energy power consumption, and the failure number. Oh, it doesn't work. Anyway. So the next case, case number 3 is an example of Inessa Group. Inessa is a major smart city solution provider in Shanghai, China. The challenge of this project is to visualize and control the operational status of the production line across the entire factory from the central monitoring room. So please have a look at this short movie.
作为传统的这个一个电子产品制造商出身的这个宜电集团的话呢，我们曾经长期占据中国仪表电子工业的半壁江山，但是在新的时期，我们也面临着这个数字化转型的这个需求。中国制造2025的话呢，是中国政府提出来的规划。我想呢，这既是世界制造业发展的一个趋势，那同时呢，也是宜电的自身转型的需要。
那在宜电显示的智能车间呢，存在着很多方面的一个数据源，那包含了我们环境方面的数据，以及生产制造过程当中的数据，那以及社会的状态，那这些因素呢，都会对我们的产品的品质产生一定的影响。那我们也想过说，在我现有的条件下，用无线的互联的方式，那进行数据的采集，以及引进大数据平台，在我们的数据分析活用方面，那进行这方面的一个解决。那在我们智能制造项目1期当中，我们和富士通合作，引入了富士通的智能生产效率智能仪表盘，以及引入了大数据平台，并在大数据上面进行了一些应用的探索，然后也在那个无线物联网方面进行了一个实践的探索。那么以前我们用传统的方法去进行那个报表统计的话，那这个甚至说有的比如说那个我们设备的进出的记录的话，它非常庞大，每个小时的话就要产生几十万条的数据，那它统计起来的话就有差不多要10几分钟以上的时间。但是我们通过 dashboard 的话，它可以几秒钟的话就可以把数据采集起来，而且可以跟现场进行一个同步。那这个在我们管理人员及时去获取信息，并采取措施进行及时的对应和改善，是帮助非常大的。
我们也期望的话呢，能够跟富士通呢，在智能制造、在智慧城市解决方案方面，能够有更多的合作，我们一起来共同拓展中国的市场，帮助更多的我们的企业，也包括我们的政府实现数字化的转型，这是我们的愿望。
Okay, next case is an example of Intel Corporation in Penang Island, Malaysia. They aim to capture the operational status of its semiconductor production line and environmental data such as electric power and water usage. So please take a look at this short movie.
Here, Intel is working collaboratively with Fujitsu to raise awareness about the benefits of IoT and data analytics in the factory.
An important goal for any factory is to run with zero interruption
and to maximize equipment utilization. Any capability to monitor and control facility and production equipment in real time has great potential to help improve factory operations and achieve world-class performance.
この工場ではパワフルな処理能力を持つインテルの IoT ゲートウェイを通じてビルのエネルギー情報や工場の設備情報などの膨大なデータが集まっています。この集まった情報が富士通のメガ IoT プラットフォームで集計・処理されています。ここにもインテルのサーバーテクノロジーが生かされています。処理されたデータは富士通のインテリジェントダッシュボードで分かりやすく可視化されて経営層や必要な部署にリアルタイムに届けられます。
This is a powerful tool to help making decisions. This shows the electricity and water usage of various buildings.
In this phase, after connecting devices, we are collecting and managing data and visualizing that data in our factory simulation environment. This enables us to equipment parameters, performance, and alarms for us to improve upon. We will further analyze the data currently being collected and visualize to identify the best operation methods and predict failure in advance.
We hope to leverage the capability in partnering factories in other industries. Intel will continue collaboration with Fujitsu to bring better IoT solutions to the world.
This is a very first challenge for Fujitsu collaboration for the smart factory in Malaysia. It was very first project. The final case is to connect workers in factories, and the case number 5 is an example of Fujitsu peripherals. And what they did in this case was put beacons on workers and forklifts here. And the beacons repeatedly transmit a signal that the other devices can see. And the Bluetooth equipment locator can detect the signal once it's in range. As you see in this slide, each devices are very simple, so they can easily start to visualize the movements of workers and the forklift in a storehouse. As you see in the middle picture, these two items allow them to visualize a series of footprints. Yeah? And footprint of workers and forklifts during picking work. As a result, it turned out that they spend 50% of all the time for picking work, but 50% out of duty time was wasted on waiting for arrival of forklifts. Now, thanks to this visualization, they are simulating to optimize the stock arrangement and considering increasing of forklift for better factory performance. Okay, let's move on to the last topic, path to smart manufacturing. Until now, I have introduced some case studies of various smart factories. There are a lot of Kaizen approaches in a factory. And what I want to say is that starting point is always collecting data. So if you want to visualize and improve something, you need digital data such as log data from machine, signal information from sensors, of course 3D design data. So my proposal is a small start with continuous improvement for smart factory. So let me summarize my presentation. In the beginning, I shared the recent manufacturing trend in the world. Especially, I emphasized to show that more than 53% of Japanese companies have positive attitude for IoT introduction. And secondly, I showed practical customer case studies as an example of smart manufacturing movement. So those case studies included various challenges in different domains. I also underlined the importance of data collection. And finally, in Kaizen approaches, I showed you my proposal that to begin with a small step and continue, the improvement will lead you to a big success. Before ending, I want to emphasize that Dream Edge and Fujitsu are collaborating together in Malaysia to provide ICT services, PLM software, 3D engineering services, and more. So I hope we will support Malaysian growth of manufacturing industry with our strong and cooperative collaboration. So that's all I have. Thank you for your attention.
Good morning, everyone. This is Sumino from Fujitsu Systems Global Solutions. Fujitsu have two locations, two offices. One is in Cyberjaya and one is Petalinjaya. My office is PJ. So today my topic is engineering data management solution for global design environment. Especially in the manufacturing field, nowadays the advance our technology has been remarkable. Today I will focus on about more designer's view. As technology advanced, not only major companies adopt the 3D design, but also small medium enterprises. Especially after 3D design adoption, the data management become more complicated because we need to handle the massive data, and design team are in multiple sites, including the overseas. And also, recently advanced the country and some parts in Japan, the design work tend to shift automatic for omitting the process of designing. In near future, it may expand in Malaysia. So I will talk about two topics today. The first one is data management tool called Concurrent Design Manager. The second is auto design tool called Auto Assembly. As I mentioned on the first page, recently there are multiple sites for design work. Not only design in each country, but also different locations. For example, Japan and Malaysia, or Johor Bahru and PJ. If team-based design from different locations, that's hard to synchronize the data. So all data from multiple sites need to be managed and integrated together. Okay, when you manage all the data in Windows Explorer, there are some issues raised. The first, you cannot see the hierarchical structure as a child-parent relation of the components. You might have the risk of forgetting to update the necessary data since you don't see the relations. Second, after 3D data, which includes assembly and parts data, become massive and complex. So it's hard to control them. Also, link relation data will be complicated, and designer takes some time for organizing and controlling the file with the version number. Here's some example of difficulty for folder management in the Windows Explorer. It causes some problem like, where's my cat data? Which one is the newest? Can you send me the drawing data now? Did you modify the related document? It seems that your site data has been updated already, but my site is still the old version or something like that. As 3D design proceeds, the data complexity will increase. Here are more specific example of problem in Windows Explorer management. The problem 1. It's very easy to do the copy and edit. As a result, many same named files are created in the same folder. Problem 2. Adding information into the file name such as version number, work date, and progress status. So you name the file according to your own rules. The problem 3. Change the design or modify the common parts without considering effect of other products. So now let me introduce Premiere Concurrent Design Manager to solve all the issues that I've just mentioned in the previous slides. FJ Premiere Concurrent Design Manager is a tool for managing design data for product lifecycle management. To be more specific, it centralizes the engineering process, data, and file for your team. This is necessary tool for a company who are already started 3D design for overall data controlling. We support 9 kinds of 3D CAD system and 2D AutoCAD. Okay, next is a feature of Premiere Concurrent Design Manager. The first is easy operation. You can use the tool with only 2 hours training. The second is a CDM. I call the CDM for design, Concurrent Design Manager to make it shorter. Okay, the second is CDM have a various functions. This provides a seamless team-based design environment operation regardless of design environment size, which is the scale of operation for or design tool type. The last one is the easy connect with the production system. Transfer the design file to BOM and mockup tools. Okay, I go for more further for CDM feature. The CDM have a replication function which can synchronize the data between multiple sites. So you can design using with the latest data and document in your own site. No need to ask your colleague to send you the latest data anymore. Okay, CDM managers flexibly expandability support company of global development. This is an example of multi-site cooperation design. There are design teams in each country, Philippines, China, and Japan. All data from each country are gathered into headquarters Japan and gathered bulk synchronized with each country. Hence, users can access all branches data to contribute information immediately. Retrieve the information immediately. And work on your task with the latest data anytime in your own site. Basically, CDM is designed to support multi-site system and collaborate with the different site members. Necessity of 3D CAD data management. There are 3 points. The first, data sharing in early phase. You're not only one member in your team to work on, so data sharing to other team members is important, especially in early phase. The second, the concurrent design. Cooperate with the related department and organize the document are important for concurrent engineering. The third, parts management. Need to handle the common parts data properly to know the range of impact for modify the common parts. Okay, this is an example of huge loss cases happened in Japan in the past. They were supposed to work on the latest version for design change. However, mistakenly they changed the design on previous version of the file and submit it as final design. Do you know what happened to this company? they lost 100 million ringgit for product recall. Okay, this is a problem of folder management I mentioned on the previous slide, and then here's the solution. CDM can solve the issue which used to have in the folder management. It becomes easier to search the requirement data with a database. So possible to keep the file relation like hierarchical structure as child-parent relation of component. And also it makes the range of influence clear. This is an use case for automotive supplier. This customer has 4 different CAD systems. Customer wanted to gather different CAD system data and cooperate with international branches. As a result, they enhanced the security, decrease of man-hour for data inquiry from another branch, concurrent design with all sites, data synchronization, and connect system with the PDM became possible. Therefore, there is no problem through a different CAD system is used and centralize them all. Develop add-ons using the API to achieve easy coordination with upstream and downstream systems. You can start out small and then gradually expand the system to achieve large-scale management. I would like to show you this video, but it has 4 different solutions instruction. The first one is, excuse me, CDM, the Premier Concurrent Design Manager that I'm introducing until now. The second is auto assembly. This one will explain a bit more after this video. The third is FJ SWOT, which is the CAE solution. The last one is over-diagnosis with AR solution, which is called 3D Chojo. It's inspection system. It's not coming out.
Department, you will see the demonstration of the cooperation of structural and manufacturing overlay diagnosis with AR with the use of the 3D model that was created by the auto assembly. We will introduce an example of the design of the inspection for the site work of the conveyor equipment. The product has the master data of models and drawings and technical documents. They are managed altogether in Premier Concurrent Design Manager. It performs auto assembly based on the order on the basis of the master data. Specify the specifications of the site work for design based on the order to this main screen. As the main screen is the Excel sheet, you can freely create a layout such as the use of images and pictures. This time, choose Customers A type for sidewalk handrail specification and 20 meters for span. Also select the specifications for the other items, then run the auto assembly. In this way, parts will be selected automatically according to the design rules only by input of the design specifications. In addition, according to the specifications of the selected part, the length of each shape will be expanded and the size will be changed, and the product will be assembled. As you can see, models and drawings that were in the specification has been created automatically. Inspection site work with span of 20 meters, specifying the main screen, has been created. It is possible to automatically generate the models and drawings of the product immediately in auto assembly. Then use the model that was created in auto assembly to make the strength confirmation. This time we will analyze this pair with FG keyword. According to the analysis result, we found that the amount of deflection is large, stretch is not enough. Load the model reinforced by adding the steam material in the CAD. It is analyzed again and see the result. In the case of this amount of deflection, it does not seem to have the problem. Now we solve the structural problems. Data you have completed the design has been managed altogether by Premier Concurrent Design Manager. Then pass the model that you created in the auto assembly to design manufacturing or value diagnosis with ER. Do the production check. In this part, we will try to overlap with what was further provisional ready. Take a photo of the actual product and capture the data. By ER technology, the age line of things from photos are automatically detected, displayed in red. If you specify the age line of models and the detected age line, the model and the photographic image will be automatically superimposed. There is no deviation of the position of the hole and the cassette plate, and it had been manufactured as designed. By design manufacturing or value diagnosis with ER, you can be ahead of schedule and significantly reduce the inspection time of manufacture and the confirmation work of manufacturing quality.
It can make process flow smoothly using the first 4 solutions like in the video. The first one is data management with a CDM. The second is auto design and assemble with auto assembly solution. The third is analyze it with a CAE solution to check strength, heat conduction, and so on. And then the fourth is inspect the product after production with a 3D Chojo. Okay, next, let me talk about the auto assembly solution. In the first slide, I mentioned that design work tends to shift automatic for omitting the process of design. Okay, our goal in design work, the first is in the sales division. Our goal is that to make a speedy estimation and improve the estimation quality. The second for design division, to reduce the designer's workload and keep quality with the standardization. The third is production division. Finalize the specification in the early stage in order to start production in advance. And make no refactoring product. I think we are using the Excel to take a note of customers' product specification during the meeting. For this auto assembly solution, and also input the product specification into the Excel sheet. For example, product size, height, depth, and if any accessory or not. Based on the specification you enter on the Excel sheet, and it will follow the design rule. It will break down into the part list, calculate the size automatically, and then auto-generate 3D model design. It depends on the number of parts. However, it can auto-generate about few seconds to few minutes. This case you see in the screen is a vertical conveyor. This can auto-generate about 10 seconds to create 3D model. This is the sample video for design power shovel. Now designer inputting the specification on the Excel sheet. and automatically calculate the parts amount. System automatically select the correct parts based on the specification. Assemble parts and making a product now. Now changing the specification again. And this time changing the shovel head model. Left side is before and then right side is after change the specification. The size and type of shovel head are changed. Next case is design change for steel tower building. Make additional hole for adding another bolt and steel bar in here. When you change the specification, like making a hole to add the bolt and steel bar, it will recalculate the number of necessary parts and auto-create the parts list. This video is designing a steel tower with a 3D model. Automatically build a steel tower based on the specification. Make holes, adding steel bars. Now try to make a hole. Now adding some steel bar on the top of the tower to make it more strength. This tool is auto-generate 3D model design tool, so you can get the idea and image of product 3D design on the screen much faster instead of designing from the beginning. So we can show you the demo in the exhibition booth today for all the product I've introduced. If you are interested, please stop by our booth. Today, the solution developer came from Fujitsu, Japan, so feel free to ask anything. Okay, that's all for my presentation, and we believe that our solution contribute to your business, shaping tomorrow with you. Thank you very much for your attention.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah rabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajmain. Allahumma aftah alaina mitaka wa asyur alaina min khazain rahmatika ya arhamar rahimin. Amin. First of all, my name is Muhammad Khalis. I'm senior project engineer from DreamEdge. I would like to start my presentation by thank you our partner Fujitsu, Miss Momoki-san, Yamura-san, and also Hasegawa-san. Thank you so much for the presentation. So I believe that presentation by Fujitsu is more about the technology. Then this technology is actually related with what we are talking about right now is about in the industry 4.0. So a lot of people want to know what is our direction, especially in Malaysia. What is our direction of Industry 4.0? So the Fujitsu member is more discuss and present about the detailing inside the Industry 4.0. So before I go more deeper on the technical, especially related with the utilization of RE in automotive, I would like to share some info about the Industry 4.0 that will be implemented in Malaysia, right? At least some idea of the Industry 4.0. Okay. Min? All right. So we have 9 pillars that been set by the government, by the agency about the Industry 4.0. We start with the 3 main: system integration, simulation, autonomous robot. About the system integration, this is what Hasegawa-san explained about CDM, to integrate all the information, to handling all this data and so on. So it's put is under the system integration, one of the example. And then number 2 about the simulation. To the simulation, it come to the where Mura-san explained, Hasegawa-san explained about the simulation of the data itself, how to simulate, to see the movement and so on, to simulate all the analysis and so on. And then I go to the autonomous robot where we combine, we integrate between the system and the robot that we have. Okay, with the data that we gather, then we put inside the system to communicate with the autonomous, with the robot system and so on. Okay, next. Then there are another 3. Big data analysis, augmented reality, and additive manufacturing. So when we talk about the big data analysis, there is one of the example that been presented by Yamura-san at the Intel or the Fujitsu others company, where we gather the information about the water, about all the information. Because previously, as mentioned by Yamura-san, we gather this information, but we never analyze this information. So where this area, big data analysis, we analyze this data in order to support us, in order to improve the process, especially making decision and so on. And then it comes to the augmented reality, where one of the example is presented by the Hasegawa-san using the 3D Chojo. So we can use our tablet to check the actual part, compare with the 3D CAD part. So we have the 3D CAD part, we go to that part, the actual part at the manufacturing, then just one snap, we can check the quality of the part. Even for the MRO, maintenance, so we have the 3D data, or we have the information, we just go to the manufacturing. Okay, for example, that we go to the machine, when we snap the picture of the machine, all the information about the machine come out. Okay, this machine must be serviced another 3 months, or the information related. So this is an augmented reality where we need to create the content of the augmented reality. And then additive manufacturing. Additive manufacturing is mostly, in easy way, is using a 3D printer to come out with the part. So we have the machine and so on. That one I will more detail in my presentation after this. All right. Next, we have the cloud, cyber security, and the IoT. Okay, the cloud, where we gather the information, the centralized area where we get all the information. We need the server, we need the system, we need the platform. So currently, in easy way, actually everybody are using cloud right now, like Google Drive and so on. So where we gather all the information. Same goes to the manufacturing or the engineering, where we gather all the information in one center. So in each area, at the company in Malaysia or in Thailand and so on, they can gather all the information in one time. And then the cyber security is about how you want to control. Because when it comes to everything is digital, there is one thing is very important, is the digital cyber security, to handle, to make sure that data cannot be hacked by unauthorized members and so on. And then the last one is about the IoT, Internet of Things, where how we want to improve all the information to become easier for us. Like for example, like we have the smart home, smart factory, smart manufacturing, and so on, so on. So this is the 9 pillars about the Industry 4.0. So when we talk about the Industry 4.0, this is where area that we should understand. And all the Fujitsu members explain is actually placed in each of these pillars. So today I want to present about one of the pillars, which is the additive manufacturing area. When we talk about the reverse engineering, we use this additive manufacturing process. Okay, all right. So if you have any question, you can just directly asking me during the presentation. Should be no problem. So my title is okay. my presentation is about utilization of the RE, reverse engineering, in automotive. So we want to talk a little bit about the automotive, all right? It's something that, the knowledge that we want to share. The team, what we did previously, we want to share with our members how we utilize this technology in automotive, okay? So we start with just some understanding and information. So when we talk about the reverse engineering, we have a tool to use on this particular activity, which is in Dream Age, we are using Ethos 2 GOM version of 3D scan. It's a blue light type. We can scan a small part as a screw up to aeroplane. Okay, it's a portable. So this is one of the tools that we use, and the software that we use to reverse to create the surface of this data is Geomagic Design X. We not come here to promote the software and the system, but I just want to give some information. At least after this, you go back, and this is the software that I should purchase or I should learn, and so on and so on. All right. So this is what we have in Dream Age. Okay. All right. So number 2, the information that I would like to share is about our client. So previously we worked with Miyazu to scan around 30 pieces of die and develop the surface. We help Modernas to scan the clay model. Even we can scan the clay model and then create the surface. Then Gemilang is at Johor. We scan the lorry chassis. All right, big as fan. So it's not very impolite, but it's actually a very big company. It's a US company with the fan. All the big fan actually it comes from the big S fan. All right, so we help them to scan some of the cover and do some analysis. We support also PHN. Okay, all right. Proton to scan their door in the latest model P213A. It's an engineering name, but in the normal name is Saga, new Saga. So we help them to scan the door and check the accuracy. We also help Bombardier to scan their glass, partition for the crack analysis. Help our client Dynamine to scan the bracelet. Launch Medical also in the medical area. We help them to scan the human aorta and mannequin to make for medical device, and also TMB Rimaco for the MRO things. So this is some of the client that using our service and the process of reverse engineering. Okay, so the service expansion. So from the 3D scan, how the engineering create the data and up what level we can make it in the final output, right? From the cloud data, for the scan data, when we scan the part, you can see the scanner outside there. When they scan the part, the first data that we receive is the cloud data, where we call it the cloud data because the data is like small dot. If you zoom in, you can see all from outside, from zoom out, it can look very smooth. But actually, when you zoom in, it's like dot. It's mostly like cloud. That's why we call it a cloud data. So there are a process where we need to convert this cloud data into the surface data. Surface data mean that into the more surface like polygon type and so on. Okay, right? Because only the surface data we can use for the engineering. For the cloud data, for the view and so on, it can be, but it's, for the engineering, they are more request for the surface data. So there are two processes to generate this surface data. They are auto surface and they are also geometrical surface. The auto surface, because we are using a Geomagic Design X. Inside there, they have two of this process. Auto surface is automatic generate. When we scan the data, just one click, it automatically create the data, the surface data, and we can get the surface data. But if you go through if the data that we scan is waving, and the data surface also will be waving. But if you use a geometrical surface, we the one that create the data. Mean that one part, we see this is flat surface. Then we need to create 1 point, 2 point, create the surface. And then this is curve. We need to modeling it manually, one by one. So we are using a geometric surface. It's case by case. Some client want using auto surface. Some client want to use geometrical surface, but it depends on time. Fastest is auto surface. Take little bit time is a geometrical surface. And once we get the surface data, we can use this data for the styling surface, packaging study, engineering design, and also quality checking analysis. So I will explain in each of this area. So from these 4 areas, it related each other. Okay, styling survey, we need a packaging study need the engineering design study, and so on, so on. And from here, we can come up with 2 items, which is one is the prototyping, and the one is the CAE analysis. Okay, and the prototyping, it can go to 2 areas. Either we do the prototype by using the CNC process or 3D printing process. So this is normal process, how we want to do all this activity. Okay, case by case, company different, sometimes they use a different method, but for us, mostly this is the normal process that we are using in our company to help client. Either they want only surface data, or they want only all these 4 items, or they want up to prototype level. So we can manage all this information easily. And from the 3D scanning up to the surface data and until here, this is where we use the CDM. So all the data is in digital. So everything is centralized. From the scan data, manufacturing team get the information, directly update to the styling surface, styling when they do the revision and so on, then we communicate with the engineering design. So this is actually the area where the CDM use. Okay, and then this is the area where the analysis, we do the analysis like the FJK SWOT or another software of analysis, and here is where the 3D Chojo we use and so on. Okay, all right, and then we go to the CNC process and 3D printing process. All right, next. 3D scanning. So this is the some process. Okay, we did some project where we need to scan a model, a car model, and then convert it into a new car, but still using a same platform. So I want to share our knowledge little bit about this activity. So the 3D scanning, we start with the setting point for the hard point. Okay. All the car have the hard point, so we set up all everything. And then from there, we calibrate the 3D scanning. Okay, we set up a dentum, XYZ, as is. Then from there, we spray some powder to reduce the part shining. Of course, certain area where it's black and shiny, we cannot scan directly. We need to use some powder to spray it on the surface. Then from there, we do the scanning process. After that, we need to sew the information to combine the surface, because this car is big. So we scan here, scan there, scan upper, below, and so on. And then after that, we need to combine the information to generate back all the image, and it will come out something like this. Okay, so this is the actual car, and this is the final output. But it's still a cloud data. We can get the information, the image of the car, but it's still a cloud data. All right. So then the same process for the interior. So this kind of activity, sometimes we only need 1 day, half day of setup, another half day is for the scanning and get the information. Okay, and then, as I mentioned, we do the scanning for the interior, same process, we analyze the data, information, and we get the result. So this is the result. This is the, what we call, the cloud data of the interior, right? Please don't ask me what model. In advance, I request to the participant. All right, next. From this car, we dismantle all the single part. Okay, from all the single part, then each part we scan. It's the same process with the first one, the second one, but the only difference is we need to take out all the part because we need to know which is the the screw part, the screw area, and so on. We need to all the details. So we need to dismantle all the part. Okay, follow the sequence because it's very important to have the sequence. This is one of the trick because if you do not follow the sequence, when you want to assemble back, then it's not become a car. Okay, it's become something. Maybe it become a car when you start the car and then suddenly everything drop. Alright? So that's why we need this sequence to understand and the engineer to jot down all the information and the process and so on. Alright? And then, same, the interior, we do the same thing, follow the sequence. Of course, the sequence we cannot share, but it depends on the company how they put the sequence and so on. It depends. But if you want to know detail, you can work with our technical team, no problem. All right, and then from this cloud data, we're using a Geomedic Design X to convert the cloud data into surface. Oh, sorry. So as I mentioned, so this is the data. So we can use either 3 process from the cloud data, mesh data, to design intent feature interaction, or to build a modeling surface and track. So as I mentioned, uses the auto surface or geometrical surface. And then from there, we can send the data to the CAD model at the, you want to use a CATIA or any software should be no problem. Because from there, we can create the engineering data design. Okay, all right. Then, come to the styling surface. Okay, from the image of this engineering surface data, actually, I put the cloud data because I don't have the engineering surface data, so I use this cloud data. Imagine this is the engineering data. From there, we make a match between the one that we sketch and the one that we scan. Okay, from here, then we can come out with the surface styling data. So this is some of the process because it has a lot of process, but here we just directly, okay, when we get the information, we directly, the styling team will inform the engineering and manufacturing, or we need this plastic, black, silver, color, and so on. They will all jot down what the color they want, what the image that they want. So, but this is the sample of the surface styling surface data. All right. So when we get the data, same goes to other area, like headlamp. We also styling, members did, headlamp, and also rear lamp. So they make all the detail and so on. All right. So from the styling surface data, another team, where we call them as engineering architecture engineering, sorry, they do a packaging study. What is a packaging study? Actually, a packaging study is a blueprint of any development. So there, all the information is very important as a guideline for the styling and also for the engineering and also for the manufacturing. All right? For example, regulation study. I not put all, but this is some example. Regulation study. We need to study in terms of regulation, mannequin. When we put the people inside there, is NG or no, or okay. Follow the regulation and cap. Follow the Europe style or Asian style and so on. So all the information we need to put there and give this information to all members from the engineering and manufacturing and styling. Also vision study, our mirror, back mirror and so on. So everything is being studied by the team. New surface position study. Okay, with the old surface and the new surface, we want to study especially the length, the height, and so on. Is it still can use the same chassis or the hard point or so on? All right, and also not forget about the block segregation for the prototype purpose. So after this, you will understand why I say this one also need to study by the packaging. So actually, we divide the car into certain block for the prototyping purpose. So you will get the idea, oh, that's why lah, okay, after this, all right? Next, engineering design. So engineering design, as you know, we have like feasibility study stage, SE, and detail. 3 stage that we need to go. So this is engineering surface design. This is some sample, right? This is a detailed engineering part. So which area that we want to go more detail. And then this is some frame structure design. So to design the prototype, we need a structure inside the car. Okay, so that's why in manufacturing team actually they design this structure inside there. Then we need to patch. We want to see the condition, is it okay or not, in order for us to develop the prototype. All right. So this is did by the engineering team. And then quality checking. That is the best thing about it. When we scan the data, the cloud data, then we can do the deviation between the cloud data and the surface data that we designed by the styling. So we can check all these things. So where this area that either the surface of the cloud data is more upper or more lower than the original, than the styling design data that we already create. So we can check from the front view, side view, rear view, and upper view. And again, please don't ask me what's the model of this car. Okay, just see it, then please do not take a picture and so on. Okay, all right. Okay. Then we do the CAE analysis. So one of the things, the basic analysis that we did is what we call is coefficient drag, CD. So you can ask the analysis members back there, because lately, why not many people know about the coefficient drag, because it's not very popular. When you talk about the car, okay, nobody talk about members. Okay, my car, my CD car is 2.80. Nobody will like, okay, all right, okay, continue. But if I thought, my car is certain horsepower, whoa, very fast. But actually, coefficient drag is very important in order to make sure the drag, the air drag at the body of the car can be reduced to the optimum. But this, of course, in the engineering is very important. That's why Mercedes success to create a car with the 1.8 coefficient drag. More lower, more better. So it's a super aerodynamic car lah. So it's lower, the coefficient drag is better. So that's why now, lately, when we talk about the car, a lot of like advertisement. This car is CD, something. Especially at German. Even the Audi also, this car, wagon car is something like CD, something. So it come to become a popular time by time. All right. So this is the process before the design improvement and after the design improvement. You can see the drag there. Okay, and here. It's different. So more focused process is more better lah. So I'm not the one who did it. Analysis team is the one who did it. The performance engineering, you can ask the detailing from this team. All right. So this is CAE analysis. Then we go to the prototyping. First thing about the prototyping, what we need to do is to design the structure. Because when you talk about the 1/2 scale car, if you want to design a prototype 1/2 scale car, it's not very huge, but it's very heavy. So you need the structure inside the car. So you need to design the structure first. Okay, this is some sample of the structure. Okay, the steel structure with the tire, everything, and the wood to cover. And because we want to slot in, it's like a Lego. This is the base. We have all the slot, everything's on. When we design, then we need to slot in the part at this base to make sure it become a image of the car. And then we scan. While we scan, same as previously, we need to do the deviation. Even this part also need to check to do deviation. That's why when we complete our part, when we check with the engineering data, 3D, is same. At least 95% is same. All right. Next, we design the part. So when we design the part, there are two processes. Either using a CNC process. This is part that we design where we use a process or CNC process. The tire, windshield, rear glass, upper sport rim, everything. We are using a chemical wood. Okay, it's a chemical wood. If you want to see the chemical wood, you can ask our team later to see what is chemical wood actually. So we use a chemical wood to create all this part. And The other process will be a 3D printing. Okay, where is the additive manufacturing come? Where all the detail is come from the 3D printing. We are using the FDM machine. You can see our machine at the Autoville. So the side mirror, emblem, headlamp, rear lamp, rim nut, everything all using a 3D printing activity. We 3D print it into a model. So you can see at the back, I think outside there, they have the front grille. The front grille, there's the logo Proton outside there. Actually, that one is 100% using a 3D printer. So it's not an actual part, it's not a fiber, it's actually a 3D printer part. Okay, all right. Then, prototyping process, we assembly the part with the CNC part and the 3D printing part. So this is the process. Okay. And see, we start assembly. We need to have this base first. You need to have this base first and slot in this area, the side panel, the tire, everything. And then we need to do all the calibration a little bit and something like this. Okay, the finishing, something like this. All right, and then we need to painting and finishing process. Okay, first the car will be the base coat painting. Okay, we need to print paint the base coat and then finishing. Okay, the finishing area. All right, next it's a continue, but the child part finishing and detailing. Because this is all the part that we detailing, process and so on. And the result, this. Thank you very much for watching. No, okay. Right. Everybody want to see the final actually. All right. So I hope nobody take the picture and so on. So the final result of this car, it will be here. Only this here. Okay. Sorry, without the management approval, I cannot show the final output, but at least you can see the car. And I would like to offer to everybody that are interested to see the car, actual car. You can ask any manager here or the staff here to go to our Autoville. This is already in Cyberjaya. It's around 15 minutes from here because of the traffic light. If not traffic light, I think around 10 minutes maybe. You can go there, you can see all the model. Actual model with your own eyes. We allow you to see it, no problem. And you can see our FDM machine, you can see our CNC machine. So actually they have another model here. So it's like a Easter egg for you lah to see all these things if you go there. So this is the output of the process. All right. So we have the prototype. So this is how we utilize this reverse engineering. Either you want the data, either you want the prototype. What we need is actually a data, a digital data. So from the digital data, everything can be done. Mean that the process to come out with the physical part, either you want to manage the data, everything, we really need a digital data. So that's why this process, based on this process, we only need around, I think 6 months to have this model. Only 6 months. So it's very rapid process to come out with a new product. So for the company like us, like this engineering consultancy, so we help the client, especially they want to create their model, they want to create their prototype, we help them on this particular process. So we help also to manage the data. When they can get the data, okay, I hope you can help us in order to manage everything. So we can help you from zero until come out with the part and so on. So this is the ending of my presentation. I hope that this small knowledge can be used by you because it's not every day that we share all the information. Of course, our engineering, actually, we cannot share this information. This is our knowledge. But when we put as a knowledge for everybody, so I think it's fair for everybody to know how the process. So I would like to give courage for those that have the colleague that want to know about the information. You can come to Dream Age to learn all this process, to understand how we run all this activity, because it's difficult to share all this information unless you come here and see it by yourself lah. Okay? All right. Thank you so much for my not so well presentation. I hope all the best can get all the information necessary. Thank you so much for your time. So this the last presentation from me lah. So can I, anybody can ask Q&A something. So please, anybody you want, I give around 1 minute if you have any question to ask me or to ask the panel here. Please do so. Again, thank you so much. Assalamualaikum warahmatullahi and very good afternoon. Thank you.
Thank you very much for spending time with us, and for Muslims, we end this seminar with Tasbih Kifara and Surah Al-As.